Today, I will introduce the working principle of the inverter to you. The function of the inverter is to convert direct current into alternating current. Let's first look at how the AC square wave signal is generated. As shown in the video, the circuit includes 4 switches, a power supply, and an output load. This kind of inverter is called a full bridge inverter. When Q1 and Q4 are closed, it outputs positive voltage to the load. When Q2 and Q3 are closed, it outputs negative voltage to the load. In actual control, 4 switches use 4 transistors. Q1 and Q4 work at the same time. Q2 and Q3 work at the same time, and the 2 groups work alternately. This kind of inverter outputs an AC square wave signal. In practical applications, the torque output of the motor cannot be smoothly controlled. How is the sine wave controlled? The circuit used to realize the sine wave is called a pulse modulation circuit. We divide the sine wave into multiple segments, and each segment is controlled by a different duty cycle, so that the average voltage of each segment is different. The higher the voltage, the higher the duty cycle. How is that implemented in an actual circuit? PWM modulation requires 2 comparators. The 2 input terminals of the comparator, one is a normal sine wave signal, and the other is a carrier signal, and the carrier signal usually adopts a triangular wave. One comparator uses a normal sine wave and the other uses an inverted sine wave. The first comparator controls Q1 and Q2. The signals of Q1 and Q2 are inverse phase. Q1 is high potential, and Q2 is low potential, so as to ensure that the 2 switching tubes work alternately. The second comparator controls Q3 and Q4 with the same control logic. The working logic of the comparator is simple. When the sinusoidal signal is higher than the triangular wave, the output signal is 1. Otherwise, the output signal is 0. In this way, we can see that the higher the voltage of the sinusoidal signal, the larger the output duty cycle. The 2 comparators use different signals, as shown in the video, and the voltage on both sides of the load is the difference between the 2 signals, and the waveform shown is obtained, so that a smooth sine wave signal can be obtained. The higher the frequency of the triangle wave, the smoother the resulting signal. That's all for today.